It's a pleasure to actually share this with the community. So I'll dive right into it. So today we'll be talking about utilizing LLM agents for effective requirement analysis and specification. So first off, we have to start with requirement engineering to understand why we want to apply LLM agent for this. So before every software product is being developed, the first stage of it is actually gathering requirement of that software in terms of understanding what the pain point is for the stakeholders. And this can be broken down into requirement elicitation, where you try to gather the having like calls, surveys to actually understand what the client wants or the stakeholders want, their pain point. And you go further into requirement analysis, where you try to analyze the stakeholders, do feasibility studies, try to understand like how possible this requirement is, and probably the various integrations that might be required. And you further go into requirement specification, where you put this into writing in terms of functional requirement, non-functional requirement, user stories, in terms of packaging this requirement that you have gotten from the elicitation process into what we know as business requirement documents, which documents this in the specification tags. Then over time, despite when you've gotten that document, you want to send it back to the stakeholders to actually validate if it's actually what they want, because this can take a course of period of time, maybe a month or 2 months, or depending on the scope of the project. You might want to go back to the stakeholders to actually, have their validation if this is what they want before you can actually push it to development. And like all product lifecycle, over time, product change, and definitely you're going to have different requirement documents. This is where requirement management comes into place. So like this, you can see that there are so many moving parts, and there are a lot of back and front with different people, and this makes it susceptible to errors, and which can lead to project delays and also bottlenecks in the projects. So there's a need for innovation, and this is where LLM agent comes into place. So on the research side of this, this is just showing the different application of LLMs in software engineering. You can see since the inception of like ChatGPT, this was a paper that analyzed 349 LLM in software engineering. And you could see a huge chunk of them was around software development and software maintenance, and barely 3% in requirement engineering. So this showed like a good and lucrative place to actually see how we can apply LLMs in requirement engineering. So first off, let's look at what is LLM agent. If you look at the top, the left, this is how we often interact with LLMs, where you open your ChatGPT or different Gemini or the different providers out there. You ask things like, okay, tell me 4 things about Scotland, and you give a prompt and it gives you a response. This is how we interact with this system. But there are some limitations in terms of we are limited to the training data, in terms of we can't get updated information, despite the fact that some providers like ChatGPT have like a search tool where you can actually search for more recent information, but there are still some limitations here in terms of also context window. If, for example, you have a document and you want to understand, you want the LLM to actually go through those documents, you can't take all those documents and put into ChatGPT because of what we call the context window, because there's a number of tokens that's allowed per time. So this is another limitation. And also due to some fact that definitely everyone that have used ChatGPT has gotten some false information most of the times, which is also known as hallucination. So with this limitation, research came into providing what we call as RAG, retrieval augmented generation, which try to solve these problems that was outlined with just using native LLMs. So in RAG, we try to get that text of document that you want to complement with the inherent knowledge of these LLMs. In this case, we chunk this data because, like I said, the context window is very important, so we can't put all the information at once. So here we chunk this document that I want to complement the inherent knowledge of these LLMs. Then we embed them. This is called indexing. So we embed this document into numerical representation, because just as we all know, computers or neural networks don't actually understand text. So they actually need a numeric representation, which is like a vector. So we index this document, and we store it in a vector store, like a database, where we can actually retrieve relevant chunks where we need it. Then when the user make a query, just like the way we make queries before, now that query, we embed it, still using the same embedding model we used to embed in documents. Now we embed that document, then we search our vector store, just like we have, like we retrieve information from relational database. But in this case, we search relevant chunks using calculations such as like similarity calculations like cosine similarities and the like, to get relevant chunks that are similar to the query. So with that, we now complement our prompt, which is the user's query, plus these relevant chunks to give it more richer context to give a better answer. However, this is just like basic naive RAG, but other advances have been seen, such as where we try to improve the pre-retrieval stage in terms of sometimes the queries might not be optimal, where we try to transform it, rewrite like the pre-retrieval stage. And also we have the post-retrieval where we try to consolidate like the documents that have been retrieved. For example, if we retrieve like 10 chunks, we might want to rank it such that the most important is up. So when the LLM reviews, it has like this hierarchy of importance, or might want to summarize, consolidate it in terms of like the context window, which I mentioned. So imagine we have like a huge like chunks and like it's not enough for the context window. We can actually summarize those chunks and add it to the prompt. So these are where advanced RAG comes into place. But however, these are still dependent on like the document and the inherent knowledge. But we can also move further to what we call agents, where, like the name says, React, which is like the initial framework for this LLM agency, talked about reasoning and acting. We are all familiar that LLMs actually have like good reasoning capacity, but we are moving further to actually use this reasoning capability to actually enable them to act, to take actions. So that's where the whole concept of React came into place. So the ability for you to allow LLMs to react, to reason, and take actions. So this is just showing you how we interact. This is all single shot inference, where we have an input to put it to an LLM, it gives us an output. Generative AI, this is how we use it. But looking at LLM agent now has more functionality in terms of it has like a perception layer, which it gets information from the user. It passes it to the brain. It takes action. It observes the environment, and it's more of like an iteration, not just like a one-off instance, just like the single shot inference. So if you go back to this paper, you can actually see that the React agent had a thought, action, and observation. So it had initial thought, which is the reasoning. Then based on that thought, it takes an action. Then based on the action output, it has an observation. What went wrong, or what did you observe from the action it taken? Was it satisfied or not? Then based off that, it then iterates to maybe have another thought or another action or another observation, and so forth. Sorry, I'm a bit fast. I'm just trying to try to consolidate everything within the 1 hour time frame. So looking at LLM core components, we have like 6 layers. We have the perception layer. This is the layer which we try to interface with the user, try to get the queries, either it be in text, audio, images. This is the perception layer. And a good scenario to actually put all this into perspective is Jarvis from Iron Man. I know some of you are Marvel characters, Marvel fans rather, and you are aware of Jarvis, which is like the AI in Iron Man suit. Most times, Iron Man might be fighting, and the AI will see some fault in the suit, reason and know that, okay, this is a fault, and tells Iron Man that he's taking certain action. So this can just be seen as like an LLM agent, but not like this advanced as Jarvis, where it's reasoning and taking action, because sometimes Jarvis helps repair the suit. That's action is taking. So you can look at it from that perspective. You can understand like the full functionality of LLM agent. So the reason and the take action. So next we have the orchestration layer. This orchestration layer is, as you see, there are different ways in which this agent works. The orchestration layer, as the name tells, try to be like coordinate the whole entire system in terms of, okay, the thought process, the actions, the observations, as we'll see. We also have the decision layer, which before it can take an action, definitely it has options there. It has options to take. It has like different paths to take, but it actually makes a decision on the best possible path to take per time. So that's where the decision layer comes in. The action layer is where the LLM agent takes action, just as the name implies. So it acts on certain tools, as we tend to see. Then also the memory layer, which can be broken down into short-term memory, which can be seen as the memory within that session of the LLM agent interaction, or long-term memory, which is the LLM agent memory over time across different tasks, as well as entity memory, in which we look at like trying to consolidate like certain entities in that session in terms of probably the name, places, like core entities, so it doesn't hallucinate. So, and the learning layer depends on the memory layer in terms of the learning layer tries to improve the agent over time in terms of, okay, what were the thought process, what field, best way to go about certain problems. That's where the learning layer comes into place. So going forward, there's what we call the function calling leaderboard. This shows the ranking of different LLMs with function calling abilities. So not all LLMs that you know can actually call functions, as we tend to see. So this leaderboard is trying to show the ability of LLMs to actually call function. So just look at it, was first derived from OpenAI, where they had like they had like this React agent go across simple arithmetics, where they had like simple Python functions such as addition, subtraction, multiplication, and division, and they had like a mathematical equation. So for the LLM to call the right function at that point to actually make that calculation was like looking at it like the function calling. So you can also see it as the ability to call tools or functions. So in the concept of tools, see tools as simply the way the LLM agent interacts with the external world. So how these LLMs actually have like capabilities to interact with the external world, be it your database, be it your Google search, be it your Salesforce pipeline, be it Hotspot, be it YouTube, how this LLM have the ability to actually connect to the external world. This can be done through various APIs, as we'll see. So in this workshop, we'll be using some certain tools to add to the capability of our LLMs. We'll be using the server dev tool, which gives the LLM the ability to search on Google. Also a web search tool, which based on the various links that it sees on Google, it wants to go into a website to run a RAG pipeline in terms of to see relevant info in a certain website. That's where the web search tool comes into place. Then we also have an archive search tool. This archive search tool, as the name implies, is search for relevant technical papers on archive. Then we also have Perplexity search tool, which uses the Perplexity AI search functionalities. And the summary index, just like I mentioned about advanced RAG, where we have like the summary and also the semantic search. So this is the tools that do that, where we have the summary index and the semantic index. Then we also have a file read tool, which just reads files, and a code interpreter tool, which tends to help for programming abilities. So in terms of agent orchestration, you can spin up your agents in different ways based on your use case. You can spin your agents in sequential order, where after one agent performs, the next agent takes over, or you can spin it hierarchically, where you have like an LLM manager, an LLM agent manager, which delegates tasks to the different agents. You can even have a hybrid. You can have a parallel and as well as a sync. So this depends on your use case. So this is just showing you the different ways in which you can orchestrate your agentic workflow. So for this use case, we'll be using 6 agents. We'll be using a requirement elicitation agent, which is going to understand the requirement for us. We also use a data analysis agent to actually interface our in-house data set, which is just like a use case to actually analyze and plot graph with Python, where we see the coding abilities of LLM agent. We also have a market research agent, which will search for different things in terms of technical market research and so forth, as we see. We have the requirement developer agent, which is going to write the requirement specification for us, as well as a compliance specialist agent, because ideally in the workplace, when you develop requirement, the most important thing, based on where you're working, if you're working in the UK, if you're working in the EU, you want to see if these requirements are compliant with like certain compliance report, maybe like the GDPR, which we are using in this use case, to see our requirements are compliant. Then also we have like a quality control analyst, which tries to check what we have done to give a final report, more of like a quality assurance. So in order to run the code, you can scan this code to interface to the GitHub repo to actually see it in place, but I'll be going right into it. Okay. Hope I was not too fast. I'm just trying to work with time. So this is the code. So first off, it's important to if you go on the GitHub repo, you will see the setup you need in terms of cloning, API keys you need, such as OpenAI, server dev tool for searching, Grok API. This is also another inference platform where you can see different models. So if you don't want to use OpenAI model, which we are using here by default, you can also see other models such as Lambda 3 as well. You can also use that, the Perplexity AI search. So in order to do Perplexity AI search, we need the API key. So this is just a quick setup for the relevant keys that we need. So you have to put them in a .m file such as this, OpenAI and stuff, because which will be using those API keys to actually use the API itself to make different API calls and LLM calls. So by default, we are using the GPT-4o mini. So just to iterate, so there are different ways or different frameworks which you can use to build this LLM agent. We have AutoGen, we have ByPress, we have Crew AI, we have LangGraph. So there are different frameworks in which you can use build your agents. But the core knowledge is still, like, the core principle is across all the frameworks. But for this case, we'll be using Crew AI for our agentic building. So here we're using Crew AI by default uses OpenAI. So we are just trying to specify which of the models we want to use. And subsequently, I'll show you how you can change your models if you want to change the model, because Crew AI uses light LLM. So they have different LLM from different providers. So if you want to, as we get to see, we'll see the different models that they provide. So if you come here, you can see the different models: Anthropical, Hugging Face, as well, or Llama if you want to run from your local machine. So we'll get to see that. So I'll run that quickly. So here we want to use a single agent and a single task use case, which each agent has a task. So where Crew AI works, in order to define your agent and your tags, you have to use like a YAM file to do this agent and tags definition. So which can be done with a YAM file. So when you're trying to define your agent, Crew AI uses role playing, which is we try to make agents like give them a role. For example, if you tell ChatGPT or to tell you something just basically, it's going to give you an output. But if you tell it to role play, probably like maybe a professor at a university, you tend to get better response. So with that core concept, Crew AI actually makes agent definition with role playing. So here, each agent has a role, it has a goal, and has a backstory. So you can see from here, we have like a senior business analyst for the first agent. The goal is to analyze initial inputs and stuff. Then we have the backstory, a certified CBAL business analyst with experience across finance, health, and technology. So this is where your prompt engineering skills come into place to get better results. So here, there's also another flag, allow delegation to be false. This is if you want to use a hierarchical process where you want the agent to to have the ability to be delegated tasks to. So you put this into true. But here, it's want to just have a sequential workflow. So we're going to put allow delegation to be false. So you can go through the various YAML file. Because of time, you can see the different prompts for the role, the goal, and the backstory. That's all you need to define your agents. So you can play around with this. You don't have to really write and find your agents like this. All you need is to sit down and compose your prompt correctly based on your use case. So likewise, the tags. So likewise, the tags, we have a description of the tags. We have like an expected output of the tags. So what tags do the agent to do? Like in this case, so we have like a single agent and single tags. So this is it. But sometimes I will get to see that an agent have multiple tags. So, but still you define the tags here with the description and expected output. That's how you define your tags. Still with prompt engineering. No code needed. This is all text. So without this, we load this YAM file. And like I explained earlier, these are the tools we are going to use. We're going to use the retrieval tools. We're going to use the search tools. So we load them. So Crew AI has Crew AI tools. If you go to Crew AI tools, you'll see the various tools that are available for Crew AI. They have like Code Doc search tool, Directory search tool, GitHub search tool, Postgres search tool, RAG tools, YouTube video search tool. You can see that. Then also, Crew AI allows you to use some tools from LangChain. To use all the tools from LangChain. So if you go to LangChain tools, whatever tool is found here, you can actually wrap it with Crew AI based tool to actually use in Crew AI, as we're going to see. So in this case, we're using the archive search tool from Llama Index. We're using this archive search tool from we're using this one for our archive search tool. So we're going to see how we can actually wrap it with LangChain. Then also we are going to also use build our RAG pipelines, as we'll see, because RAG pipelines can also be a tool for our agent. So because in order to interface the compliance document, which is the GDPR document, we want to have like a RAG pipeline. So whatever requirement we have, we're going to search for relevant compliance chunks that are relevant to that user's requirement, in order to like give it good compliance checks and reports. So we are going to build RAG pipelines of that document. So we can also use Llama Index to build those pipelines. So here, like I said, we're using the archive API wrapper from LangChain Community Utilities. Then also using the tools from Crew AI. So here we're going to use the base tool from Crew AI to actually wrap this tool and have like a run function which executes the tool. So that's what I'm going to do. Then also, you can also build your custom tool. So this is a custom tool for Perplexity Search AI. If you go down to Perplexity AI documentation, you can see how the API works. So based off this, the way the API works, all you need to do is to put your content. So based off that, I built a custom Perplexity Search tool for this, with content just being the argument, and which is here. So this is the argument I'm changing. So whatever argument, whatever content we pass in the search content here, and Perplexity AI tool runs. So this is just like a custom tool. So you can build your custom tool, whatever API you have. That shows you the possibilities, because like these tools are scoped based on what the the provider of this framework actually do, but you can actually build your own tools for your own use case. So this whole code here is just trying to build the right pipeline in terms of using like this vector search store index to build the semantic search index, this document summary index to build the summary index. So this is just using Llama Index to build the right pipeline. I won't go into detail because of time, but the code is well commented in terms of like creating the using ChromaDB. So ChromaDB is like the vector store, just the way we have a relation database where we have like table name, but here we use like collection name. So collection name houses that like vector set, that embedding set rather. So that's what we will use in terms of initializing the ChromaDB and stuff. So this was just building the query engine. Based off this, we're going to create the query engine tools, which is the summary tools and the semantic search tools. So okay, so I don't want to run this again. So I'll just put this to be true because I already ran it before. So I'm just trying to reload those embeddings rather than running it from scratch because of time. So next, we import agent, tags, and crew model from Crew AI. So here now we define like the agent properly. So based off the config file, we use like the agent to actually define them, as well as access to tools that they need. So for example, the requirement extension tools, we are providing the inputs like manually, does not have a tool. So it's not compulsory for an agent to have a tool. If it does not have a tool, it's going to use the inherent knowledge of the LLM to actually complete that task. So for the market research tool, so we are giving it this separate dev tool, the website search tool, the archive search tool, Perplexity search tool, which are also for the market research. So the agent is going to choose per time which of the two he wants to use. This is not in our restriction. So requirement developer search developer agent does not have any tool, just specify the agent definition. The compliant agent, the compliance specialist agent now needs the GDPR summary tool and the GDPR semantic tool to actually search through the GDPR document, which can be found here. So if we go to input, we will see the compliance document, which is the official GDPR document. So it's searching through this document for relevant chunks. You can see how long this is. Imagine we're copying this and putting definitely to be beyond the context window. So the RAG pipeline is spinning off this document. Okay, so yes, so this is the agent definition. So so next we define the task. So and we specify which agent is in charge of that task. So just the way we did it here, we're using the config. We put the task task configuration from the YAML file. We specify the agent, and that's that. Then if you want like an output, so we want a final output from the last agent, which is the quality assurance agent. So we have like an output. We specify what where the output should be and the file name. So here we want the markdown. So we specify that. Then creating the crew. So as simple as calling the crew model, putting the agents in the list, putting the tags in the list. Verbose means I want to see the output as the agent is executing. So verbosity. So we can spin up our crew like this. So these are inputs. So our inputs. So are you still with me? Okay. Okay. So our inputs, we're trying to build a solar analytic mobile application. So this was just the first solicitation where they are introducing the vision of a mobile app to track, monitor, and analyze solar energy. So that's the input. So if we run this and kickstart agent, so you can see the first agent has started. So the first task from the YAML file say, okay, thoroughly analyze the inputs. So this was the first task. This was the final answer from that agent. So the next agent begins. This is a sequential order. So it starts conduct a comprehensive market research based on the initial prompt we have in our task. So these are the thought process. So, okay, I need to gather relevant market data. So this is the thought process. It says using which tool? Using the search tool, which is the Deva tool. So it chose to use the server Deva tool. So it searched different links. It was not still satisfied. It still searched more. So it still said search the internet. It still searched for more results. So he said I encountered an error while using this tool, which is possible because this is like different API, but our application does not fail. This is why agency is like more of like a fail safe, because when the agent has errors, it doesn't break. Instead, it tends to find solutions around it using other tools. So since the search tool was giving errors, it went back to, okay, I'm going to search a specific website. The website search tool instead of the search tool. So I encountered some issues. While using this, you can see how it's fail safe. So it's searching, still searching other papers. You can see. So based off the search, this was the final report he gave from his search. He did his SWOT analysis, and now he gave that market research to the senior requirement engineer, which is the next agent, to actually specify the functional and non-functional requirements. So this begins to spin. So this produces a draft document. Now the draft document is then passed to the GDPR compliance specialist. So he said assessing the draft BRD to ensure compliance. So he needs to assess the tool. What tool does it call? It calls the summaries tool. Next, it calls the vectors index tool. So based off that, you can see it has a compliance analysis of the BRD. Also has mitigation strategies, compliance frameworks, DIP reports. Then also we have like the quality assurance, so look at everything. And if you go down to our output, we actually have the final document from that agent, putting everything all together. So the business requirement document. You can see how the agent actually worked very fast and like a BRD from just the initial meeting. So you can see how this can actually make the requirement engineering process faster, because after initial call, you can actually spin up this agent to actually get a requirement document and share with stakeholders as quickly as possible. After just a minute, this took less than how many minutes rather, you can actually get it and say, okay, based off the meeting we had, this is the first draft. you can review it and make the to and fro process a bit reduced. So next, we'll go to a single agent and multi-task use case. So in this case, an agent has the possibility to have multiple tasks. Also, we'll see how we can integrate other LLMs, like I said, using Light LLM. We'll also look at code writing agents, as well as planning moment and memory. So if you come into Light LLM, you can see the different LLMs that LLM providers. So for example, you want to use Grok. Grok is free in terms of, but it has like a rate limit that you should be aware of because it's open source. It's free, rather. So if you come into Grok, it tells you how to specify the name with Grok / model. So using that concept, we are going to use the Llama 3.170B Versatile, which is 3.170B Versatile, this model. So we're going to use Grok / this model. I think it's kind of one of the biggest model on Grok. So we'll use that. If you want to use Anthropica, you specify it as this as well. So if you want to use Anthropica model, you go to Light LLM, see how you specify Anthropica models. So Anthropica models, you just need to specify the name Anthropica / this. So that's how you specify the model. But for Anthropica now, you have to have like key credit in your API to actually your API key to actually use that. So let's use Grok LLM. And here now we're trying to improve. We are adding like a brand voice analysis task to the agent to actually understand, like analyze the brand. So in this case, we have like an additional document here called more of like a brand voice. I don't know if I can open it, but I'll push everything to GitHub, just like telling what the brand about, to just have like to know the tone of the company. So we'll be actually creating a tool of that, more of like a RAG tool to actually understand that. So that's where we have this doc search tool. So you can see it's indexing it to ChromeDB, like the vector as well. So now we have updated the agent definition because we want to add more. I want to add this data analysis agent, the Python data analyst. So we've added that. Then also the tags, we also added this brand voice review tags, analyze the available information about the company, and also the data analysis tags. So those are the addition. So for that, we run this. And also we want to also plot the graph. So we want to use this this CSV, it's a small CSV file of the different energy generation from Africa. So we want to use that as well. So we created a CSV tool. So just the way we defined it, we're using a file read tool from CrewAI. So as you can see, it's from CrewAI. So this is how you define it. You just put the part of the file and it spins up. So for the agent creation, just the way we do. But now let's say we want to change the model from the default GPT-4. So we can use LLM, the LLM attribute to specify the LLM here. Grok LLM, we have already defined it earlier up as this. So we want to use the Grok LLM for just the elicitation agent. So we can have different agents running on different LLMs. So next up for the data analysis agent, I want to use a bigger model. We don't want to use the GPT-4o mini because we need like coding ability. So we need to use like big models for this. So we'll be using GPT-4o. Let's say we want to use Anthropica, we can also specify it like, but this is okay for now. So we can run this. So also note for the coding ability, they have on safe and unsafe version. So by default is safe, which is a Docker. So in order for you to run this, you have to have Docker installed, and so you have to have Docker installed and run. It's going to spin up a Docker container to run the Python code inside. So that's that. So we define the tasks we have done earlier with the different agents. So we also have what we call context. So context is where we put dependencies. So for example, we want task A to depend on task B. So we'll put task B that has a context of task A. So more of like context. So it needs task A to work. So in this case now, requirement elicitation guarding task won't work until the brand task is done because it has a context here as the brand voice review task. So that's the context. Then if you want it to run in parallel, you use the ASIC execution. So for example, wanted brand execution, brand voice and requirement execution to run in parallel, we can actually put both to be async execution equals to true. So they're going to run in parallel. So this is just the task definition. So next, we want to create our crew. So just like we did earlier, we have the crew, we put the agents in a list, we put the tags in a list, verbose equals to true. Now, all the memories I talk about in terms of short-term memory, long-term memory, entity memory, in crew AI, all this can be turned on by just setting memory equals to true, as simple as this. Then if you want to have like planning agent, which is going to be another additional API LLM call, because now we're going to use another LLM to actually plan the whole execution. You can also set this as this plan equals to true. They will specify which LLM you want to use for the planning. Then for hierarchical process, like I mentioned, you put the agent delegation equals to true. Then you can also change the process here. By default, it runs by sequential. But if you want to change it to hierarchical process, you put it as process dot hierarchical, and also specify the manager that is going to delegate those tasks. So that's just that. If you want to try it, you can play around with that. I'm just going to keep it simple. So let's kick off our agents. Just like we did before, but now we added like the data analysis agent. So we have the brown voice tags already being implemented, done by the elicitation agent. Yeah, you can see it's still running. It's still the senior business analyst, which is the first agent. While this is running, is there any question? So this is still the agent running. That are we in on now? Let's check. This is still the brown voice. Okay. So this is what I was trying to say. Now we have some issues with light LLM in terms of probably the rate limit. So let's kill this. Let's rerun it again. Or this time, let's change it to the basic GPT-4o. Change that agent from Grok. Let's just change it. Let's use the default GPT-4o. So let's rerun. Let's rerun it again. So you can tell how it works. So you can try different LLMs. But that's why I say that there are different ranking, the function calling to function calling leaderboard that shows you the different agent with their different LLM calls. You might be tempted to say, okay, I want to use like local LLMs like on Llama based on your laptop, but most times from experience, those models like might not be able to call certain tools or might not be able to call like certain tools, so they tend to hallucinate. So that's why we have like that function leaderboard to show you that different LLMs that have the ability to call tools. So so this agent still running, and also you should be aware of terms of quality. If you want speed, smaller models, but there's a trade-off: is either speed or quality. So if you want like more detailed analysis or more detailed generation, you might want to use like bigger models, but will be slower than like small models. So it's a trade-off in terms of quality and speed. So that should be you should be aware of that. And also, like if you notice this use case, we actually made the coding ability to be GPT-4o, which had like better coding abilities than the 4o mini. So the data analyst has started looking into the data, the CSV file. Data analysis is looking into the data, the CSV files. You can see it's putting the ember. So from the prompt, it's analyze and plot a graph of the data it sees. So there was no definition of, oh, use this library. It's going to make all the decision in terms of, should I use Panda, should I use NumPy, should I use Matplotlib? It's going to take the whole decision by itself. That's the whole concept of agency in terms of the level of automation for this LLM, so decision themselves. Okay. So you can see said I'm supposed to conduct analysis to identify trends over time in solar distribution. So this is the code. This is import pandas. This is just it writing code, like I mentioned. Load the CSV file. He ran into some errors. It's going to fix itself. So this is like the whole concept. It's not perfect. It's going to make mistakes. So most times this is where like the time execution takes longer in terms of the agent trying to fail and try to resolve the errors and stuff like that. So it's not certain. So that's why, like, for some tasks, you need to use like better like LLMs. So for example, you might want to go and check, okay, which LLM is good in coding, or which one is better at maybe data analysis and stuff like that. You can do, there are different benchmarks, or do more research before you implement in your use case. So while this is running, I can just go through the other slides, the other cells. So when we get there, we can just quickly run through it. So Korea has a testing feature, which tend to use LLM as a judge, where we use like an LLM to actually judge the outputs based off the task definition. So how well does this agent do this task? So we are using LLM as a judge. So like the gold standard is human evaluation, where we use humans to actually evaluate the output, but that's not scalable in terms of you actually have to have a human being to actually scale it. But with LLM as a judge, you can run like 5 iterations of the LLM pool, have like the average. So using LLM as a judge. But so far it's like these tools are open source. Contributions are being made, but currently Korea just supports GPT 4.0 as the LLM as a judge. Ideally, you're supposed to use like an independent LLM from the one you created, because it might be biased in terms of its own. Imagine you're judging an output from ChatGPT and an output from Anthropica using ChatGPT as the judge. It's kind of biased because it was used to get the output. So ideally, you should use an independent LLM. But so far, this is the one they have right now. So you can contribute and improve it. So, but currently, it's just the GPT-4 open source models that can, open AI models that can be used as the LLM as a judge. So this is what, like, it gives you a score based off the different tasks and the agents, as we'll see hopefully before time runs out. So then also training feature, just as the name sounds, training, you're trying to train the agent. So in terms of trying to give it human feedback. So after each agent execution, you are prompted with like a dash, like a prompt to ask you, okay, how well do you think the agent ran? So you can actually like you can actually improve in terms of saying, okay, I want you to improve this, maybe based on the test scores that we got. Maybe let's say from the test score, maybe the data analysis task was not done very well. You can ask, okay, based off the score, I want to improve the figures. Maybe I want to make it bigger and stuff like. And I give human feedback. So that's the whole idea of training. So that's just it. I hope we can see the ending of it. So it's still having some issues and she's trying to fix it. So she's trying. So it has plotted it. It's trying to save. It's having issues saving it. It's trying to save the output. I have 10 minutes. I hope everything runs. So things are even getting more complex in terms of Korea has what they call flows, where you can now group like this crew. This imagine this requirement in your is a crew of agents. You can have multiple crews where we have like maybe a software engineering crew, a marketing crew that is composed of its respective agents. You can now combine that as well as sub code like Python code to like making decisions and have like this agency and your own code run together. What we call like using the through AI flow. So those are like for more complex use cases. But for ideally, you start off small. You start off with the tools I have in at your arsenal. You start off with the tools you have. You see what agents you can spin up. Are they relevant or not? You look at the prompting. So you start off small and you build up with scale. So that's like the most important thing because they can get really complex. So I actually plotted it. If I just have issues to save it to the out out output folder, because this was the folder it was specified to save it. Just having issues plotting that, but probably that's why it's taking a lot of time. But that's like the general overview of how you can like spin up agents and like so all the codes are on GitHub. My username is codebrain001. Or probably let me make this public. So if you just go to code 1001, DevFest Scotland, you have access to the code. Let's see. So stuff like this now, when you're training the agent, definitely is having a hard time. It's having a hard time to plot the graph. So these are things that you can actually implement in the training, but you can see this is all Python code. So you can see matplotlib as PLT, import OS, import string IO. So this is the agent actually porting code using the code interpreter too. So it's you see that it's possible. So probably it's just the output. So when we are training the agent now, in this case, you cannot actually improve on it because initially when I ran it, it actually plotted the graphs and stuff. So you can actually make this improvement yourself and like just okay. So the first thing, just try to get access to the code on GitHub. I'll make it a public um after this session. So you just go there, like run the script, get the Docker installed, install the requirement files, and you are good to go. So you can actually test this stuff out. So I don't know why it's still running. We can take questions if there are any. And any questions or any thoughts?
There are no questions so far on the chat, but please feel free to add your questions or comments.
Okay, so you can see the chart. You can see the chart. So after all the time it took, he actually plotted the graph. So the solar energy consumption in Africa. So he actually plotted the graph. So he plotted the graph. So it took a lot of time. So like I said, it depends on the agent's capability. So after he's plotted the graph, he moves to the next agent. So that's the process. That's one of the bottleneck which is sequential and hierarchical process. So imagine we're running this thing in parallel. Probably the market agent would have spinned up, but this is just like a real life scenario. So that's the thing about live coding. Sometimes so there are circumstances that you don't see. So it took a lot of time. We actually plotted the graph, which is this. So we moved to the market agent. This was moving faster, so there should be a problem. So whenever I face issues like I miss the action, it resolves itself. So you can see how long it actually took for it to like solve the errors itself to get the plot. So that's just showing you how this agent works. So like I said, you can actually improve it using the training features, or you can actually test it to see how it performs. Definitely the data analysis tax is going to be low. If you can run it before the time goes off, you see that it will be low because it actually took a lot of time. So the agent did actually perform the task well initially. It took a lot of time. So those are things that the LLM as a judge is going to put into consideration when grading. So this just shows you what is possible. Just shows what's possible. So functionalities, and just play around with it. Check the repo, CodeBrain 01. Definitely by the time you're watching this video, it should be up and running on GitHub, CodeBrain 001. Check for DevFest Scotland, and you see the whole code and the outputs for you to check out. Thank you very much for joining my session. I hope it was insightful. And I'm keen to hear for what you're saying. You can check me out on LinkedIn, Brain John Aboze. You can drop your questions and we can also have further conversations.
That's great. I love this. I love this presentation. Thank you so much. There is a couple of questions in the chat. First, what types of other integrations have you tried?
Okay, so good question. So for like integration, like someone said, Jira. So yeah, like I said, there are so many companies that are building tools. So you can also check Composio. I've actually built some integrations with Composio. So Composio also has some different tools. So you have things like Jira, you have things like GitHub, you have things like Trello board. You can actually build this yourself using like the different APIs that these integrations provide, like I did with Perplexity AI. Like here now, if you want to use Perplexity AI, it's as simple as using this is a code for actually using it. So this Perplexity AI search. So you can actually use it with Crew AI. You can see how it is already here. But I actually built it from scratch, like using the API itself. So there are so many tools. You can check out Crew AI tools. You can check out LangChain tools. You can check out Composio. There are still more tools and more tools being like pushed out. I think Hotspots even release some agentic tools as well. So you can actually check those. Yeah.
Okay, amazing. And I guess that what we will do is that as soon as we upload the video into our YouTube channel, we will share in the description of the video the link to the repo. Brain, will that be okay?
Yeah, that'll be okay.
Great. Okay. Well, thank you so much. Thank you everyone for joining. This was really an amazing one. Brain, we want to thank you again for giving your time on a Friday night to share your knowledge again with all of the GDG Glasgow community and for being part of the Scotland online sessions. And for the rest of you, we're going to keep on having online sessions. So we hope to see you around and yeah, enjoy your weekend. See you later.
Thank you. Bye. Have a great weekend.
Thank you. Bye.